Yeah, so nice to meet you all. My name is Vladimir. I'm VP of Engineering at FrontierX, and today we want to talk a little bit about our technology to build what we call secure containers. And of course, everybody here is very well familiar with confidential computing. So we're thinking the angle we want to show you is how confidential computing can help prevent breaches, data breaches. And this is how we we market our product. We are a startup, so we want to sell it as kind of a easy way for people to onboard in confidential computing, but at the same time, we it's fully open source, so we everybody can look at the code, verify it, use it themselves. Yeah. So when we look at the news, these kind of breaches happen often, and they happen even to the companies with the best kind of security teams. So um, it's very hard to stay protected. And we were thinking how do these breaches happen? And we've been looking into some of the past big breaches and trying to kind of put like the causes into four categories. One is just misconfigured data access policies. So people forgetting to make a bucket private, for example. Um, One is unauthorized access to machines processing data, right? If an attacker gets access to the infrastructure, they could SSH into a machine that runs some operations and then download data. Um, and then we have leaked credentials, either of service accounts or employee credentials, that are somehow privileged to access some data access, encryption keys, and so on. And the kind of group, why this happens, um, and we come to kind of two conclusions. First one is data is encrypted during processing, is not encrypted while it's processed. And the second one is that privileged accounts have easy access to keys. And by this we mean, for example, if you use like a CMAC, it's often even transparent. The decryption becomes transparent. So these kind of accounts, if they are compromised, it's kind of easy for them to get access and decrypt the data. So the question is, how do we prevent this from happening? And in a lot of the calls, we're asked about certificates, and you can do SOC 2, SOC 3, ISO, and so on. But since we are not on the compliance automation consortium, the answer is not certificates, and it's surprise, surprise, it's confidential computing. So what can you do? How can confidential computing help? And of course, we can just run something on AMD SAV or Intel TDX. We get encryption in use, and that's great. But now our data is actually not stored into the TE, it's stored somewhere outside, and the keys are also stored externally. So we also need to somehow prevent the keys to only be able to be used in the TE, right? We can use remote attestation and so on. But then, this still doesn't mean that nobody can SSH into the machine and actually inspect the data, right? There could be like a super user account that has this ability. So what we are also looking at is how to um, basically enable the key to be released in the TE only if you can attest that the machine, you cannot get direct access to the machine. By direct access, I mean SSH. And then what if somebody, deploys a compromised account, deploys a new software version to this TE that actually starts leaking the data, right? So ideally, we also want to achieve attestation of the workload that's running inside and to have a approval process and say, okay, we are only um, allowing the key to be released and the key to be used to decrypt data by this specific software version. And so this is much more difficult than just, running your workload on a machine with AMD SAB enabled. In fact, we've actually started using computational computing for some internal products, and we saw there's actually quite a lot of work to build all this infrastructure. So we wanted to make it easy. And for this, we try to make a product out of all our internal efforts um, to protect ourselves and our own products so that this can be useful to other people that may have similar challenges as we have. And this we call Polaris secure containers. And the main idea of Polaris is to be a transparent wrapper around your containerized workloads. So you can think about it, if you have some kind of application or backend or processing pipeline module, if you have a Docker container running on your infrastructure, you can put a wrapper around it by using Polaris. And this wrapper tries to be as transparent as possible, meaning that you don't have to change anything or just minimally. So Polaris makes sure we run your workload inside of a confidential VM. So either AMD SCV SMP or Intel TDX. Polaris helps you provision your encryption keys, provision the remote attestation checker, and configure all the policies to properly. And also as an optional add-on, Polaris can provide like a transparent layer of encrypted communication on top of what you already have. And Polaris itself, I like to think it consists of three kind of packages. The first one is deployment automation. So currently we have it on the Google Marketplace and Azure Marketplace, and we are working on a Terraform provider and Helm charts that you can use to deploy. And it's always on your infrastructure, where you don't run any part of the stack. The second is the runtime library, or the so-called Polaris proxy, which can be used to proxy all requests and encrypt and decrypt the communication transparently. It also helps you with getting access to the keys to decrypt the data. And then the third part is the developer SDK that can be used if you want to have more things encrypted and decrypted, and for example, store them in a database. So it's basically like a set of utilities to make it easy for you to use it. And before we dive into the kind of the technical details and how this is implemented, just to kind of make clear some of the assumptions we have developing Polaris. And the first one is we want to build, we're a small startup, and we want to build on top of the latest and greatest from the cloud service providers, right? So we are gonna use services that are already available. And what Polaris does is basically makes it very easy for you to use all these services, deploy them, configure them properly. We want to be opinionated about the security configuration, meaning that we don't want, if you want to use Polaris, we don't want to allow you too many options to shoot yourself in the foot and configure something wrongly. And we want to hide as much as complexity as possible from the user, because our target clients are people that are not very familiar with confidential computing, but that care about this additional level of protection that can be offered. Transparent wrapper, we try to not get in your way and not require you to do any kind of modifications. Some parts at the moment still would require you to do something, but we are working on one by one removing these requirements and making it as transparent as possible. And the last one is everything runs on your infrastructure. So we help you deploy, but everything is running in your tenant. So we don't have any kind of component on our end. And we want to, everything we do here is open source. And you can find the main things on our GitHub, with the SDK being Apache 2, and for the Polaris proxy, it's AGPL3, and you can basically purchase a license through either the Google or the Azure marketplaces. And then let's take a look at the overall architecture of Polaris. So in the center sits your workload, right? So if you have any kind of Docker container running, it continues to run there. In the same node, we deploy the Polaris proxy as a sidecar container. it is the only component that's allowed to talk to the outside world. And you can enable optional encryption and decryption of requests and responses. Um, Currently on HTTP level, but we're working on TCP level proxy as well. And the proxy is going to help you manage access to the keys, to the attestation policy, and then the key that's stored in some kind of HSM service. We have an option to also add a GPU, a confidential GPU with a confidential PCI Express bus, um, currently only H100s. And you have currently the ability to use the Polaris SDK to encrypt things for external storage, but we are also working on making transparent, different types of storage transparent. So just attach them and um, you can work with that. So now we can deep dive into the details. So for the trusted execution environment, we use confidential VMs or confidential um, containers on the cloud providers that support it. And the idea of Polaris is to be cloud agnostic. So we basically have the automation and basically the functionality to connect to kind of currently we are on GCP and on Azure with AWS. Support for AWS is on the roadmap. We also support confidential GPUs. Currently, the technology is GA, general availability only on Azure, but we're also in the private preview for Google to enable this, because especially the case for confidential AI and confidential LLMs seems to be a hot topic right now. And then for how this kind of combination of the two containers looks like, as I said, the current Polaris proxy supports HTTP communication only. We already have prototypes for TCP level. And then when the encrypted request comes in, the proxy decrypts it, sends it to your workload, and then encrypts the response. So your workload actually doesn't need to know anything about encryption and decryption. And this communication is internal to the CPU, basically. So it's in the memory that this communication happens through is encrypted. And it's an optional feature that you can enable. And then the key management makes sure that you connect to you perform the attestation, remote attestation in the proper way for the specific platform, send it to the KMS service, get it verified, and then get either credentials to the key or the secure key release, depending on the platform you're running. And for your workload, it's just like configuring a standard Docker container. You can configure the image, arguments, entry point, variables, and so on. It's very similar to how you would deploy a Docker container or on the respective cloud platform. And the encryption attestation, we support different ones. We have a version that's you just uses ephemeral keys that are created inside of the TE. It's obviously not very useful if you want to have some kind of permanent storage. And then we support both on GCP and Azure. Their respective HSM offering, we always do asymmetric encryption with RSA 4096 bits. And for the attestation policies, we always check that the request comes from an AMD SAV-SMP environment with optional checks and attestations for you're running an image that has SSH disabled, that you're running a whitelisted service account, or that you're running a whitelisted Docker image hash. And in the way how we use it, for example, this kind of key and attestation policy sits in another organization. So there are no admins that have access both to the data and to the key and policy. For the encryption, so we use encryption, as already mentioned, on the HTTP protocol level or TCP, where the content of the packages is encrypted. You can also use it from the Polaris SDK if you want to currently store something on a bucket storage, for example. And What we do is we use kind of an integrated encryption scheme where we can use RSA encryption to encrypt a symmetric encryption key, to wrap it, and then this key is then used for with AES 256 GCM to actually encrypt the large chunk of the workload. So the advantage of this is that um, you can use private public cryptography. So I can get the public key of the machine and I can encrypt already something and send it to the machine without needing to exchange private keys. And at the same time, EES 256 is obviously highly optimized and very efficient. It has efficient implementations on all kind of platforms. And we offer, as I said, the Polaris SDK, which is basically a set of utilities you can use to make your life easier. That abstracts all the complexity of creating the attestation and getting access to the key. It gives you all the encryption routines with this scheme, gives you helpers for HTTP communication, can be used both on the browser or on the backend. Go implementation is currently under work. And to give an example how we use this internally is what you can basically use Polaris is to create an end-to-end encrypted chatbot. And this we developed for one of our internal products. So what happens here is you have your LLM server and rack application run inside of a Polaris container, right? Polaris container means we add the Polaris proxy and we enable encrypted and decrypted output. This means now that you have some kind of chatbot application that has a front end, it has some back end. On the back end, you have a bunch of encrypted documents that you want to use. This is some kind of company documents you want to use in the rack context. And they're encrypted with a key, with the public key of the TE. And the corresponding private key is stored here in some kind of KMS service with an attestation policy in front. Now, what happens is if you want to make a request to the LLM, you go in your browser, you make the request, you type in your prompt, it gets encrypted in your browser, goes to the LLM, gets decrypted there, passed down to the rack. So the rack doesn't need to know about the encrypted HTTP communication. The rack can then fetch the encrypted documents. Usually what we do is we have embeddings that don't have any critical information, then we find the relevant documents, we fetch them, and then you can basically get this access to the key inside of the TE to actually decrypt the documents. Pass them to the LLM server, generate the response, and send it back encrypted directly to the user's browser. So in this way, we completely circumvent the need to go anywhere on the backend, meaning that we kind of have an end-to-end encrypted communication with the LLM server. With every step along the way, the data stays encrypted. And even this document, right? How we upload the documents is we encrypt them on the front end. When you send them out to the backend, they're already encrypted using the public key of the container that's gonna read them after. Right? So there is at no point this document was visible in unencrypted form along the chain. Now, one thing that you cannot do here directly or not simply is in this kind of LLM chatbot applications, you usually want to store your chat history, right? Which is could be quite sensitive, especially if it contains some kind of confidential company information. So one way to go is to basically put the database that you use in the backend inside of a TE. When you're working on this use case, but I wanted to show something else that we actually do. And again, with the use of confidential computing, is to say, okay, let's actually give every user a personal asymmetric encryption key that they can use directly from the browser. Right? The idea is I encrypt my messages, store them in the backend, and then when I want to read them, I fetch them from the backend, and I decrypt them live in my browser, so that I can avoid having the backend at any point see the content of the message. And this is another thing where we use Polaris containers for. Um, so we're now the user. We are in our browser. The application has loaded the front-end code and running it. We authenticate with some kind of the identity provider. As long as they support OpenID Connect, it can work. And what we get from the ID provider is an ID token. It's a JW token basically stating your identity. This could be signing with Google, with Microsoft, or any kind of modern authentication system can support this. And then we fetch the chat history, so it can be any data, plus the wrapped AES-256 key that was used to encrypt the data. Fetched in the browser, this data is useless without the unwrapped key. And now we have a backend system that again runs in a Polaris container, which is like a simple key management API. What it does is it stores the private asymmetric keys for every user, basically indexed by their identity. And in this case, it's the email address. And then it's actually also indexed by the issuer of this identity token. So I can say, okay, for this email, if they log in with Google, you get this private key. And again, the keys are stored encrypted, only allowed to be decrypted inside of the T. And this essentially means you have your personal encryption key stored for you inside of a TE in the cloud, and that you can access if you can provide the corresponding ID token. So you provide the token, you provide the wrapped key. We authenticate that it's you, unwrap your key, and send it back to the front. And this part actually never saw the actual data. It just saw the unwrapped key. And this part actually never saw the encrypted data, but never sees the unwrapped key. All things come together in your browser, it gets decrypted, and you see it live. So this is basically this extension how we can add this support for message encryption in the browser. And so we have 4 types of containers for different use cases. More simple ones we call Polaris. Polaris Pro adds the ability to use permanent storage, and we have special variants for AI and LLM that add some kind of, let's say, syntactic sugar to help you run easily AI models and LLMs. And that's basically it. Yeah, you can find all the open source components on GitHub. We have put here links to the docs and to the kind of product page. And then I was thinking if we have time, I could do a very short demo, basically just showing you how the deployment process works. So what you see here is so we have here a repo with examples. In this case, we have a very simple anonymization service using the scrub-adopt Python library. And then we have a client application that can communicate with it, right? I have my service here, and this is now deployed without any confidential computing. This is just a bare minimum deployment. I can just submit requests, and it's gonna anonymize my data. Right now, the question is, okay, but what if somebody can actually get access, or the cloud service provider do a memory dump? They could actually see this sensitive information, so I want to protect it. And I just want to walk you through the process of deploying a new container, which takes about a minute. So I'm going to go to the Google Marketplace. I'm going to select Polaris Pro. I'm going to say launch it. And as I said, you'll be able soon to do this all from your Terraform deployment using Polaris. I think I'm at number 9 now. And then you can just configure basic parameters that are typical for Google deployment. I'm gonna select an account that's gonna deploy this. You can also create a new one. I'm gonna select an N2D machine that supports confidential computing. Gonna use the default service account to actually run the application. I'm gonna stay default on the disk and the network. In order to demo this, this allows us to have a firewall exception rule that kind of allows everybody to talk to this container. And then we can configure different properties of the Polaris proxy. I'm going to enable input and output encryption. I'm going to enable CORS so we can talk directly from the browser. And then I need to configure my workload. I'm going to use just our anonymization service, which we've published on Docker Hub. I can just plug it in. And here I can configure things like entry point, environment variables, and so on. But this is not needed here. And just click deploy. And that's it. So this now takes a couple of minutes to deploy. So I'm going to use a service that I deployed just before to show you. I think it's interesting to see the encrypted communication. So I'm going to switch to this IP. And then if I submit the request, it's going to fail, right? Because we are now trying to submit it in plain text. And we've enabled encrypted communication, so I need to do this. When we do this, what happens is you see we first fetch the public key of our container and then send the data encrypted with this public key. And we send the wrapped key for the symmetric encryption. This passes through the proxy, gets handed to the workload and gets encrypted back. So you can see also the response is encrypted and decryption happens live in the browser. And the last thing I want to show here is we also have an endpoint that shows you the attestation. So we can also verify it from within your own, from your front end. So this basically fetches the attestation token, verifies it with the help of the Polaris SDK, and to show you it's verified. And if I come back to the deployment is ready. I just want to show you that. So this is all the infrastructure that get deployed. So it's basically the a service account, a keyring, encryption key, the workload identity pool, and the provider with the attestation policy, the VM, and the firewall rules. So this is all kind of done automatically for you. So yeah, that's all from my side. So open for any questions.
Okay, that was a very complete demo. Thanks for that. So I'll open up to questions. Usually we want one to kind of seed the flow of questions. So I don't know if you're familiar with CNCF Coco. That project tries to allow you to target confidential computing using your existing Kubernetes workflow, and also tries to shield the container from the control plane. As I looked at your material, I gather that's not the approach you're taking with Polaris containers. Instead, you are, I think the focus is the proxy and enabling some sort of attested key release and then subsequent encrypted communications with that container. If I got that
Yes,
wrong,
although deployment on Kubernetes is one of the areas we are working on, right? Our goal is to make it very easy for people that are not familiar to run this. And we've also focused on this kind of direct browser application to container communication, as we think this is one of the areas that may be interesting, or certainly were interesting for our use cases.
Yeah, that makes sense.
Yeah, we see very often decision makers about if are you using confidential computing, being CISOs or similar, that are not like with a super deep background, and when they see that a solution is wrapped and packed in this way, it makes it much easier for distribution of the solution, right? Makes it much easier for us to convince people to utilize confidential computing because there's a prepackaged solution basically.
Yeah, it's nice to see it up there on the marketplaces. Other questions from the audience? Well, I think that you have done an entirely too clear job of presenting so that we are not left with any questions. I think that was all pretty clear to me. So thank you for introducing us to the proxy. I think I've dropped the right link to the proxy code in chat. We do like to focus on the open source aspects of this, so people are welcome to go take a look at that.
Thank you.
Excellent.